Video I'm going to present an introduction to soil composition. Some objectives for this video are that you should be able to recall what constitutes a soil. In other words, the soil components. What are the components of a soil? Second, you should be able to describe the building blocks of clays. And thirdly, you should be able to explain why clays behave differently than sands and gravels. First, let's talk about what is a soil composed of. So what I'm drawing here are some soil grains, solid particles. In between these soil particles, you have voids. And inside those voids, we can have fluids, and that's what the blue coloring indicates, fluid inside those voids. And in addition to the fluids, we have gases in the voids. And so again, the brown circular type shapes represent solids, blue line represents a fluid, and then the other space represents a gas in there. The fluids that we are going to generally talk about in this course are water. The gas will be air, and then the solids are the grains, the soil grains themselves. Those soil grains are composed of gravels, sands, silt, and clay particles. Gravels, we can define gravels based on the size of the particle, and so those range in size from 4.75 millimeters to about 76 millimeters in size. Sand particles range from 0.075 millimeters to 4.75 millimeters. Silts range from 0.002 millimeters to 0.075 millimeters, and then clays will be those particles that are less than 0.002 millimeters in size. One thing to note is that these definitions, especially the size of the clay size particles, can vary from one soil classification system to another that they're used, but these are some general guidelines of the sizes of these particles. Now we're going to focus on sands and gravels. Sands and gravels have similar type behavior. Oftentimes they're composed of similar minerals. Primary minerals for sands and gravels is quartz, and this the chemical symbol is SiO2 for silica dioxide. The behavior of sands and gravels is governed by gravitational forces. So the forces that are pushing the particles together are significantly controlling their behavior. Other things that control the behavior of sands and gravels are the packing of the particles. This could be the relative density or the void ratio, and we'll talk a little bit more about void ratio later and what that specifically means. The particle shape can be a controlling factor in behavior, as well as particle roughness. So we go back and talk a little bit about the packing of particles. This could also be the orientation and the way the grains are packed together, in addition to just the void ratio or relative density. So that gives you some basics on what sands and gravels are composed of and what controls their behavior. And when we talk about the behavior of these materials, we're talking about things such as the strength of the material, how much strength it has against shearing forces, primarily, or how compressible the materials are. Now I'll present some information on clays. So we'll start off by talking about the building blocks of clays. The building blocks of clays consist of silica tetrahedral sheets, and a silica tetrahedral sheet um, is represented by this trapezoidal shape. And then there are aluminum or magnesium octahedral sheets, and will represent this chemical structure by a rectangle. The aluminum sheet we'll refer to sometimes as a gibbsite sheet, and a magnesium sheet as a brucite sheet. As I stated, we represent these sheets with a rectangle. So these are the basic building blocks of clays, and what makes clays what differentiates one clay from another is how these building blocks are combined. Some of the common clay minerals uh, are one, kaolinite, and as we talk about kaolinite, we'll look at the mineral structure of kaolinite. Kaolinite clay consists of a gibbsite sheet and a silica sheet, and so we'll have multiple layers of these sheets together. And between each of these building blocks of gibbsite and silica sheets will be they'll be bonded together by hydrogen bonding. Why this is important is because it prevents hydration, or basically a lot of water getting in between these sheets and causing swelling. And so kaolinite clays are clays that you don't expect to swell significantly. And that's important because as we're building structures, and if they're resting on clays, um, obviously we don't want there to be a lot of swelling or shrinking of that material. So a kaolinite clay is one that's not going to experience significant swelling or shrinking as a result of the hydrogen bonding that binds these particles together. Another common clay mineral is Montmorillonite. The building blocks of Montmorillonite are a silica sheet. Below that, you'll have a gibbsite sheet, and then another silica sheet. So that's the basic building block. And then we'll have a number of these building blocks connected together to create the clay minerals. Something that's important and different about Montmorillonite than the kaolinite, as well as in addition to the building block, is that between each of these building blocks you have a number of water layers or H2O layers and exchangeable cations. Another important thing is that the bonding between these building blocks, the bond is by van der Waals forces, and what's notable about that is that the van der Waals forces are a weak bond, and so that allows for more water to penetrate or to build up around and between the building blocks of the clay. As a result, Montmorillonite has the potential to display significant swelling and shrinkage as the water content changes. Soils with the potential to expand, swell, and shrink significantly as the water content changes. We refer to these types of soils as expansive soils. They can occur anywhere throughout the United States. They are definitely predominant in the southwestern United States, and they can cause significant problems for structures that are built on them, roadways, any type of construction. These expansive clays can cause significant problems to the serviceability of the facilities that we're trying to build. So it's important to be able to recognize these type of clays and then understand how can we change their behavior. Water in between the building blocks of the clay, it's not just pure water. You have ions or cations inside that in the water, and the cations affect the bonding between the sheets. Thus, the cations have an effect on the clay behavior. They have an effect on the expansion potential of the clay as well as the strength. When we talk about Montmorillonite, a common Montmorillonite is a sodium Montmorillonite, and the sodium is a cation, and we can, if we put some calcium in that clay. So one common source of calcium is lime. It's calcium hydroxide. If we mix in lime with this sodium Montmorillonite, the calcium cation will replace the sodium cation in the Montmorillonite, and that will then reduce its expansion potential. And so, understanding the chemical nature of the clay and what we can do to change their behavior through the use of cation exchange can be used and it can be helpful for in applications to geotechnical engineering. And finally, the attraction of water to the clay particles is what gives rise to a property which we call plasticity. Plasticity is a word that we use that describes the response of the soil to changes in moisture content. So when the consistency of a soil changes from hard and rigid to soft and pliable by having water added to it, the soil is said to be exhibiting plasticity. That plasticity range is greater for soils that have high attraction to water like Montmorillonite compared to clays like kaolinite, which aren't as strongly, have as much strong attraction to the water. So that gives a brief introduction now to soil composition, to what constitutes the soil. Again, that's the soil particles, the fluid, and the gas that can fill the voids. And then we've talked about those soil components that make up the soil. We have the sands and gravels that are governed by gravitational forces, and then we have clays that their chemical nature becomes important, and their attraction to water becomes important in their behavior. So that's that introduction then to soil composition.